Okay, guys, college algebra, we have a couple reviews for the upcoming unit quiz on Unit 1. So, what you can do is start to summarize. I did it for you in this first unit, but what are the basic things we did? There are these keys that are throughout the entire lesson, but we started out factoring the greatest common factor. So when you see something like this, you've got two things to look at: the number that they have in common, and then also the variables. So if we look at it, if I factor out, say, a -3, because 3 and 9 have that in common. If I look at the a's, I see a to the first and a squared, so they will have an a in common. I see b squared and b, so they will have a b in common. And then write a parentheses. And now it's all about backtracking. What do I multiply a -3 by to get -3? Well, that's just going to be a 1, so I can write that. What do I multiply a by to get a? That's 1. What do I multiply b by to get b squared? So that's just going to be b. Okay. And then I look at, what do I multiply a -3 by to get a +9? That's going to be a -3. What do I multiply a by to get a squared? That is a. What do I multiply b by to get a b? That is just b. So your answer is -3ab, and then b minus 3a. Then we had a formula for the difference of squares. When you recognize two perfect squares with a minus sign in between them, take the square root of that first term, 5x, minus the square root of the next term, and then 5x plus 4, and you're done. Sometimes this difference of squares crops up repeatedly in a problem. Look at the next one. When you take this one, that's x squared minus 4, x squared plus 4. But always ask yourself, can I go further? X squared minus 4, that still is the difference of squares. So your final answer is x minus 2x plus 2, x squared plus 4. We have no formula for the sum of two squares. It's only the difference of two squares that we can factor. Now what you always want to do is the greatest common factor, if that is applicable, do it first. So when I look at something like this, what do they share? They share a 2. So if I factor out a 2, I'm left with 4x squared minus 9. Now I've got greatest common factor, and what's in the parentheses is the difference of squares. So I can factor this as 2. 2x minus 3, 2x plus 3. And I'm good to go there. Grouping. Remember what I said. Grouping is the only factoring method we have for factoring something with 4 terms. What you want to do is just break this into 2 separate problems. Look at the first 2 items. What do they have in common? They have an x squared in common. So if I factor out an x squared, I'm left with 3x minus 1. Copy down the next sign you have, which is a plus sign. Look at that 6x minus 2. They have a 2 in common. When I factor that 2 out, I'm left with 3x minus 1. If you've done this correctly, what's in the parentheses should match, and you are left with x squared plus 2 times 3x minus 1. Then we did factoring of trinomials. So with trinomials, you need to find 2 numbers that multiply to give you that one and add to give you that inside number. Things that multiply to 21 and add to 10, that's going to be a 3 and a 7. And because this is an x squared, not a 2x squared or 3x squared, you take these numbers, you go straight to your final answer, x plus 3, x plus 7. Now, if you're factoring with grouping, if the trinomial has a number other than 1 in the front, then you need to look at this a little bit differently. You need to multiply to get 2 numbers that multiply to give you, what is that, 4 times -2, that's -8. So 2 numbers that multiply to -8 and add to 7. So multiply to -8, those factors are going to be 1 and 8, 2 and 4, but it's going to be the -1 and 8. Those multiply to -8 and add to 7. I use those numbers to rewrite this problem as 4x squared. You can write it as minus x plus 8x minus 2. It doesn't matter if the 8x is first or the minus x. Then you factor this by grouping. So you look at this and say, okay, those first two terms have an x in common. So that's 4x minus 1. These next two terms have a 2 in common, 4x minus 1. This answer is x plus 2, 4x minus 1. Okay. Then we went from factoring to solving. The key to solving equations, set the equation equal to 0 and then use our factoring methods. Okay, always try greatest common factor if it can work. In this one, I can factor out a 2x, and then I'm left with 2x minus, excuse me, made a mistake there. So factoring out a 2x, so when I factor out a 2x of this equation, I'm left with x minus 2 equals 0. Now I'm fully factored. I got factors multiplied to give me 0. So that means that 2x equals 0 or x minus 2 equals 0. This means that x equals 0 or x equal 2. Those are my two solutions. Look at the next one. It's already set equal to 0. The factoring method here is going to be difference of squares. X minus 6, x plus 6 equals 0. That means that x has to equal plus or minus 6. The next one is a trinomial. To factor this, I'm going to need two numbers, remember, that multiply to give me a 3 and add to give me a 4. The numbers that do that are going to be 1 and 3. So I'm going to write this as x plus 1, x plus 3 equals 0. So x is equal to -1 or -3. The next one is a trinomial. I need two numbers that multiply to give me a -6 and add to give me a 5. So it looks like that's going to be -1 and +6. So I'm going to rewrite this problem as 2x squared minus x plus 6x minus 3 equals 0. Factor by grouping. X, 2x minus 1 plus, and then I can factor out a 3, 2x minus 1 equals 0. So x plus 3, 2x minus 1 equals 0. Therefore, x is equal to -3 or 1/2. Those are my two solutions. X equal -3 or 1/2. Now, after we solved those equations, we moved into two other kinds of equations. Rational, that is equations where we have expressions in the denominator of a fraction, and then we also had radical. So rational, there are a couple things here. The first thing you should do is look at the denominator of that fraction. That presents two things that I need to be concerned about. Those numbers can never be 0. So x minus 1 cannot be 0. X plus 1 cannot be 0. So this means that x cannot be 1 and x cannot be -1. So these are the exclusions, the restrictions, the domain restrictions, okay? So I'm going to go solve this problem and make sure that I don't think the answer in the end is 1 or -1, because those will not work. Now, the way to solve this problem, you multiply everything by the denominator. So the denominator is going to be what? X minus 1, x plus 1. So I'm going to multiply both sides of this equation by x minus 1, x plus 1. And this should simplify for me. The x minus 1 over x minus 1, that is 1. X plus 1 over x plus 1, that is 1. So I'm left with x plus 1 times 1 equal 2 times x minus 1. This tells me that x plus 1 equal 2x minus 2. If I can add 2 to both sides, and subtract x from both sides, I will get 3 is equal to x. So x is equal to 3, and that does not violate the conditions that I had over here. So that's all good. X can't be 1 or negative 1. Okay? Now, from there, we moved on to things that had radicals. So square roots, cube roots, and things like that. Now, the key here is you want to isolate the expression that has the square root. So here I've got 4x plus 12, the square root of that, equal x. Now, you've got a restriction that we're taking a square root. So when I take a square root, I can take square roots of positive numbers. So that means that 4x plus 12 is, it can't be negative. So it can be 0, but it cannot be negative. I can't take the square root of a negative number. So that means 4x plus 12 has to be greater than or equal to 0. That means that 4x has to be greater than or equal to negative 12. X has to be greater than or equal to negative 12 over 4. X has to be greater than or equal to negative 3. So I'm going to get an answer. And that answer had better be greater than or equal to negative 3 for this to be valid. Now, the way you solve this problem, since you see a square root, is you square both sides of the equation. And that gives you 4x plus 12 equal x squared. Now, to solve this problem, I really want it equal to 0. So if I subtract 4x and subtract 12, I get 0 equal x squared minus 4x minus 12. To solve this, I need two numbers that multiply to negative 12 and add to negative 4. So it looks like a 6 and a 2. A negative 6 and a positive 2 will make that happen. So this is going to be, with a negative 6 and a positive 2, x minus 6, x plus 2 equals 0. That tells me that x equals 6 or negative 2. Okay? And then I have to check. These numbers had better be greater than or equal to negative 3. 6 is greater than negative 3. Negative 2 is greater than negative 3. So both of these solutions will work. The other way to check this is I can take both of these numbers, I can plug them in the original equation and see if that gives me a true statement. Now, so those are just a review. What you see next is me working through what was a sample test. Okay, factoring. This looks like the difference of two squares. So 6x minus 5y times 6x plus 5y. If I look at the next one, okay, it's a little bit confusing. I don't quite see perfect squares. Let's see if there are anything that they have in common. It looks like they have a 7 in common, but they also have 21. 42, if you divide that by 2, you get 21. So 21 is the greatest common factor of those two numbers. Look at the x's, x squared and x. They have an x in common. Y squared, y fourth. They have a y squared in common. So what do you multiply 21 by to get 42? That's 2. What do you multiply x by to get x squared? That's x. What do you multiply y squared by to get y fourth? That's y squared. Then I have a minus sign. What do you multiply 21 by to get 21? Well, that's just going to be a 1. What do you multiply x by to get x? That's 1. What do you multiply y squared by to get y squared? That's 1. So here is your final answer. 21xy squared, 2xy squared minus 1. Factoring the next one. 3 terms, quadratic. I'm going to use the method of finding two numbers that multiply to negative 28 and add to negative 3. So 28 can be 1 and 28, 2 and 14, or 4 and 7, and then it turns into 7 and 4. These are the only choices. So, excuse me, they have to add to be -3. So if they add to be -3, this has to be a -7 and a +4. Those multiply to -28 and add to -3. So this is x minus 7, x plus 4. Now this is not solved. There's no equal sign, so I'm done. I'm just being asked to factor here. Now the next one I'm being asked to solve. There's an equal sign. If I'm being asked to solve something like this, I want it equal to 0. So x cubed minus 7x squared minus 9x plus 63 equals 0. The only method we have learned to deal with something with 4 terms is grouping. So what can I factor out of the first 2 terms? It looks like x squared. If I factor that out, I'm left with x minus 7. Copy down the minus sign. What can I factor out of the next terms? It looks like a 9. So I factor that out, I get an x. What do you multiply -9 by to get a positive 63? That's minus 7. So it looks like I get x squared minus 9 times x minus 7 equals 0. Always keep asking, am I done? No, that looks like the difference of 2 squares. This is x minus 3, x plus 3, x minus 7 equals 0. You set each of these factors equal to 0 to find that your solution is x equal 3, -3, or 7. Those are your solutions to this equation. Now the next one presents a rational expression. Keep in mind, every time I see that, highlight the denominator, because you're going to do 2 things with the denominator. It tells you your restriction, and it tells you what to multiply by to solve this. Okay, the restriction is whatever that I highlighted, 2x plus 1 cannot be 0. That means 2x cannot be -1. That means x cannot be -1/2. This is my restriction. I'm going to go find an answer, and always check to make sure that it's not -1/2 in this case. So what I highlighted there, 2x times 1, I have to multiply that entire equation by 2x plus 1. The reason I do that is it's going to simplify the side of the equation, or every time I see a fraction. So now I get 15 equal, this is what, 2x squared plus x. This is a quadratic. I don't like it equal to 15. I want it equal to 0. So I can rewrite this as 0 equal 2x squared plus x minus 15. And now I am looking for 2 numbers that multiply to give you -30 and add to give you 1. Numbers that multiply to 30 and add to 1, that looks like a 6 and a -5. So I'm going to rewrite this equation, 0 equal 2x squared plus 6x minus 5x minus 15, factor by grouping. So 0 equal 2x, x plus 3, minus 5, x plus 3. That gives me 0 equal 2x minus 5 times x plus 3. Setting each of those equal to 0, I get x equal -3 or 5/2. And neither of those violates this condition. So both of those answers are good. Looking at number 4, I'm a little bit strapped for room here, but we can manage that. I've got a square root sign. So that's going to present a restriction. What is under that square root? X minus 1 cannot be a negative number, so it has to be greater than or equal to 0. That means that x has to be greater than or equal to 1. So I'm going to go get an answer, and I need to make sure that it's greater than or equal to 1. The way I solve this problem is I square both sides of the equation, because that is a square root. So when I square both sides of this equation, I get x minus 1 equal 25. I add 1 to both sides, x equal 26. This number had better be greater than or equal to 1, and it is. So that solution will work. Another problem with a square root, okay? What are the restrictions? So you look at what is under the square root. X plus 2. I cannot take the square root of a negative number, so that number needs to be greater than or equal to 0. That means that x needs to be greater than or equal to negative 2. So I'm going to go find answers, and they had better be greater than or equal to negative 2. The way I solve this problem is I square both sides of that original equation. So x plus 2 equal x. Square both sides of that equation. When I square both sides, I get x plus 2 equal x squared. I want this to be greater than or equal to, I want this equation to be set equal to 0. So x squared minus x minus 2 equals 0. So I need numbers that multiply to negative 2 and add to negative 1. That looks like that's a 1 and a negative 2. Multiply to negative 2, add to negative 1. So this means x minus 2 times x plus 1 equals 0. So x is equal to 2 or negative 1. My solutions had all better be greater than or equal to negative 2. So 2 is greater than negative 2. Negative 1 is greater than negative 2. So when I check these answers, they should work. So another way of doing this is check these answers. Let's plug those numbers back in. So square root of x plus 2 equal x. And here's a case where, like I said, as I talked in class, you really want to check your answer. The domain restriction tells you whether or not the square root is valid, but to figure whether or not it really solves the equation, you got to plug the answers in. So I've got 2. If I plug in a 2 here, the square root of 2 plus 2 equal 2. So that's the square root of 4 equal 2. 2 is equal to 2. That is good all day long. So good solution. Let's plug in a negative 1. So square root of x plus 2 equals x. So let's plug in a negative 1. Negative 1 plus 2, the square root of that, equal negative 1. This means square root of 1 equal negative 1. Does 1 equal negative 1? That does not work. So the only solution here is x equal 2. X equal negative 1 doesn't satisfy the original condition. Okay? So that's why you're going to always need to check your answers on these square root problems. A few examples of solving here. I need this equal to 0. So I need two numbers that multiply to negative 12 and add to negative 1. So those numbers should be negative 4 and 3. So this is 6x squared minus 4x plus 3x minus 2 equals 0. Factor by grouping. 2x. 3x minus 2 plus 3x minus 2 equals 0. That means that 2x plus 1, 3x minus 2 equals 0. So x equals negative 1/2 or 2/3. You get that by setting each of those factors equal to 0. This one, I need two numbers that multiply to negative 22 and add to negative 9. So 22 is going to be 1 times 22 or 2 times 11. So it looks like it's going to be negative 11, positive 2. X minus 11, x plus 2 equals 0. So x is equal to 11 or negative 2. Looking at the next one here, this appears to be the difference of squares. So 2x minus 5, 2x plus 5 equals 0. Set each of these equal to 0. You get 2x equal 5, x equal 5 halves. This next one is going to give you x equal negative 5 halves, and you're good to go there. And the last one here. It's already set equal to 0, so I just need to solve this. It looks like what I'm going to be able to solve this is the greatest common factor. I can factor out a 2x, and I'm left with 2x minus 5 equal 0. If 2x equals 0, that means that x equals 0. If 2x minus 5 equals 0, that means 2x equal 5 or x equal 5 halves. So those are your two solutions for that. So that's the end of review part 1.